Welcome to another live CSEC class. Tonight we're going to look for our graph session. We're going to look at transformations and looking at enlargement. And before we go into that, here's our schedule of live classes. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, guys, so let me see who's backstage. Imani, John, are you there? Asar?
Hi. Yes.
Good night. Welcome, guys.
Thank you, miss.
Asar?
Hello, sir. And yes. Hindi man.
All right, so we're going to look at enlargement.
Yes, enlargement.
Hold on. Where's the maximum? Okay. So then, I need to share my screen. Oh, hold on. That's something I need to do first. All right, so you see in the screen?
Yes.
Yes, miss.
Yes.
All right, so as you know, I'm not fully versed. So let's hope this works, okay? so
Okay, miss.
so let's draw some points. So let's say we have A and we have B and we have C. Now we're going to connect them to A to B to C.
Miss, could I do it?
No.
Miss, could I do it?
Do what?
Wait your turn,
Could I
child.
enlarge it?
She's going to give us in order.
I'm the youngest.
All right, so with the enlargement, no. Of course, you know, enlargement means it's gonna get bigger, right?
Yes, miss.
Yes, miss.
Right. So the orientation will be the same, but the size definitely is not going to be the same. So we have what we call a scale, and we have what we call a center of enlargement. Hold on. So oftentimes you're told that the center of enlargement is the origin, right?
Yes, miss.
And so that would mean, what that would mean is this is where you're going to focus, and you're going to connect each of these points to the center. But the center of enlargement can be anywhere on the coordinate plane, right?
Yes, miss.
Can be anywhere on the coordinate plane. But that is we could call it an axis, right? That's where everything originates. And then it's either going to go further in the same direction or even in the opposite direction, depending on whether the scale factor is positive or negative or fractional. We're going to focus on positive tonight, and the scale factor we're going to use is 2. And we're going to say that the center of origin is 0, 0, which is right there. Okay, that's the center. So what we're going to do is, so the scale factor is 2. So we're going to connect each of these points to the center. So you would take your ruler, right? And you would get from the center of origin, draw a straight line running through each of the points. So that's the first thing you do. Keep it straight all the way. So since the scale factor is 2, so you're going to extend each point by 2. So you could actually take your ruler and measure, so the distance from here to here, and double that. Or what you can do on the coordinate plane, you can see how many places you move to get to the original and double that to get to the new point. So for example, for this first point, A, from the origin to A, we moved 1 on the X and 2, right, on the Y.
Yes.
So if we double that, it will be what?
Miss, that would be 2
2
on
to
the X
4.
and 4 on the Y.
2 on the X and 4 on the Y. 1, 2, 3, 4. That will be here, right? For B, we moved 3 on the X, 1 on the Y. So
Okay,
it will be
so
what now?
miss
6,
the 2.
6 to 2.
Yes.
And for C, we moved 3 on the
4
X,
up.
4 on the Y. So it will be what?
Miss 6 to
6
8.
to 6 to 8, which will be here.
Yes, miss.
Okay. So now we can connect those 3 points. So it will be that to that. So this is our new triangle,
Yes,
and
miss.
it has been enlarged by a scale factor of 2. So this is the original triangle ABC, and this is the image of that triangle. You could label it A prime, B prime, C prime.
Yes, miss.
Yes, which is normally what we do when we're comparing the object to the image, the original thing to what we end up with. So we start off A, B, C, and this will be A prime, B prime, C prime. Do you remember? Do you remember what we said about? Remember when we're doing scale factor and area?
Miss,
You remember
Miss,
when
when
we
we were
did?
doing like the scale factor is 9, and like the
So if the scale factor is 2, how much bigger would this triangle be than this triangle in terms of the area?
Miss, it would be 4 times bigger.
And how we got that 4?
Miss, because we would double each of the we would double it the spaces. So because we would
Not
double
double
each the
it, we
space.
would square. We would
Oh
square
yeah,
this.
square it. Sorry. So because we would square it, the area would end up being squared as well.
So we'd multiply the area of the small one by the scale factor squared. So if the scale factor is 3, the area would be 9 times as big as the object. Scale
That's
factor is 2,
oh,
the
it
area
would
of
be
the
four
image is 4 times as big as the original thing. Asar, are you with us? So let's do another one where the center is not 0, 0, right?
Yes, miss.
The center is not the origin. All right. What did I do? What am I doing?
I don't know.
Why don't you students teach me how to use
Miss, we don't know how to use it.
you guys need to teach me how to use it.
We don't know how to use it.
You don't know how to use it all this time and you see me fiddling with it so long.
Miss, I don't use GeoGebra, miss.
All right. Suppose the center of the enlargement is here. That's the center, right?
Miss, at 5?
Huh?
Oh, okay.
So what would be the coordinates? What would be the coordinates of that center?
Miss, -2 to 5.
-2. So the center of this enlargement is -2, 5. And let's say the scale factor is 3. Okay.
Yes.
All right. So I'm gonna start with gonna try and make it tiny so that it can hold on the thing. All right. So let's hope it can hold. I'm gonna make it tiny. So let's make it. So let's say that's that and that. All right. So from that to that, and it don't have to be a triangle. You know that, right?
Yes,
Yes, miss, it
miss.
could be a square.
Any
Um,
shape, any shape.
hexagon.
Whatever. All right. So the center of enlargement is here at -2, 5. Scale factor is 3. So first thing we do is connect the center, run it through each point, right?
Yes, miss.
The center happens to, I'm not gonna do it like this, should I? I don't want the two
Miss,
of them
just do.
to,
Miss, just use the buttons. Miss, just use the undo button at the top.
the what?
Miss,
Where?
the undo button. Miss.
This one?
Yes, miss.
But then I have to undo so much.
Alright.
I'm going to, I don't want all the points line up with the center. So I'm going to put one there and one here, okay?
Okay.
Okay, so that's to that. No, what am I doing? Guys, wanna give me for drink this evening
Who's
here?
ever give you anything to drink? Miss, don't use that.
But I'm doing pure madness.
Miss, just you. Okay, Miss.
I'm
Miss,
doing pure rubbish.
Miss,
So-
Miss, when you
okay.
go back on the line thing, Miss, just go on the line segment.
No, I need a line segment. Okay, from that to that to that. So this is our triangle.
Looks so
All
small.
right. Yeah. So now we need some rays now to connect from the center running through each point, right?
Yes,
Yes,
Miss.
Miss.
All right. Through each point, make sure. All right. So we said the scale factor was 3.
Yes.
All right. So for the first point, we did what? Straight across 3, right?
Yes, Miss.
1, 2, 3. So 3 is 9. No, so
Yes, Miss.
so
Miss.
that would be
Wait. Oh.
9. 9 would be here, right?
1, 2, 3.
Yes,
All
Miss.
right. For this one now, we went 1, 2, 3, 4, and then up.
Orange.
So 4 is 12. So it will be 12 and then 3.
Miss 12 and then 3.
12 and up 3. And for this one, we went 1, 2, 3, 4 and down. So it will be 12 and down 3, which will be here.
Yes. Yes, Miss.
All right. So now we need the line segment to connect. So from there to there to there.
Miss, can you please just put the screen down a little bit?
To the what?
Miss, can you please just put down the screen a little bit so we can see the last part of the triangle?
I can see it.
Hold on, hold on. You want me to shift it? You want me to move the
Yes.
Go
screen
down a little bit.
like that?
Oh, that's
Yes.
good, Miss.
Yes.
Like that.
Yes.
Yes, Miss.
Okay, all right. So this is our original triangle. This is our center of enlargement. The scale factor is 3. So we could have used our ruler and measure the distance from the center of origin to the point and then just multiply that by 3 to get the length to the extended point. We could do that, right?
Yes, Miss.
Same thing for each point. Get the measurement, multiply it by 3 to get the new measurement. Same thing for there, straight down. Since we're doing it on this software, it's easier to do. We just get our rays and join the points and it will extend it in a straight line. And then we can just count the coordinates and double and triple the coordinates.
Yes, Miss.
So the area of this triangle would be how many times the area of this triangle?
9.
Miss would be
9 times the area, right? The area of this enlarged triangle with the scale factor of 3 would be 9 times the area of this triangle, scale
yes.
factor of, um, well, yeah, scale
Miss,
factor.
can I please go get some water?
Okay, so we're just gonna do one more. Next week, we'll look at what happens when the scale factor is negative
Okay.
and when the scale factor is fractional.
Fractional?
Yeah.
When the scale factor of
So
a half,
you'd have to square the fraction, Miss, to see how much larger the enlargement would be.
well, I don't know. By next week, I'll find out.
Okay.
So,
John, help her to wash her hands.
so we're going to draw. Uh, Let's draw a trapezium or something like that.
Okay, miss.
So this is our center of enlargement, right?
Yes, miss.
And the trapezium, let's start with it close. So that, um, that, that is gonna expand out. So let's connect these dots. So from that to that to that to that to that. This should be right here. All right. So um, that's the trapezium. So I'm gonna need to kind of shift it like that. You think a scale factor of 4 could hold?
Um.
You want us to try?
Okay,
Let's
miss.
try. Let's try and see if a scale factor of 4 could hold on this. All
Okay.
right. So first of all, tell me the coordinates of the center of enlargement, which is
Miss, the
here.
center of enlargement would be -7 to -5.
-7, -3.
Oh yes, -3. Sorry.
All right. So -7, -3. All right. So if the scale factor, we need to write the scale factor is 4. So scale factor 4.
It's going to be really big.
It's gonna be big. I'm wondering if it can hold. All right. So let's put in our rays
Yes.
connecting. So from there straight through here, and from here straight through here, and straight through here, and straight through here.
Yes,
All
miss.
right. So now, for the first point, it was 2. We moved 2 on the x and 1, right?
One on the Y. So
So
now
multiplying each of those by 4, it will be what?
it would be 8 on the X, 4 on the Y,
8 on the x and
4 on the Y.
4. Okay. So 1, 2, 3, 4, 5, 6, 7,
6.
8. 1, 2, 3, 4. That's here.
1, 2, 3. Yes, miss.
And for this one, we
That
had
would
to move 4 and then 2.
So that would be 16 on the X and 8 on the Y.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7. We barely made it. Barely made it, guys. Barely made it. All right, for this one now,
We go
2
2
across,
on
1
X.
down.
Yes,
So
miss.
that's 8 across. 1, 2,
Um,
3, 4, 5, 6, 7, 8, and 4 down.
Miss 8 is under F. Miss 8 is under F. And then 4 down.
What do you mean under F? Oh, here.
So that would be the eighth box across.
1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. So it to be here?
Yes, miss.
No.
Miss 1, 2, 3, 4, 5, 6, 7, 8. So it's -3 to 1, 2, 3, 4,
It will
-7.
be on this line. I need to shift it.
Yes, miss.
So I need to come up little.
Sorry, it's it
Yeah,
would
so it will be 1, 2, 3, 4 and down. to be on
Yes.
this.
Yes, miss. Yes, miss.
And this one no. 4 across,
Um,
1 down. So that's 16.
16 to 4. So 8, 9, 10, 11, 12, 13, 14, 15, 16.
So right here.
3, 4. Yes, miss.
Okay. So now we need to connect them. So that's that to that to that. Um, Shift it down. To that and to that. All right, so we barely made it.
Yes, miss.
Yes, I'm back, by the way.
You're lost. So
No,
that's the enlargement scale factor 4.
Miss, I was saying I was back.
Oh, back. Okay, so this is our original trapezium, and we have enlarged it. The center of enlargement was -7, -3. From the center, all lines go out, radiating. And this trapezium is how many times the area of this one?
Miss, would that be 16?
16 times as large.
16 times as large as this one. Because we have to square the scale factor. If we enlarge a shape by a scale factor, the area of the larger one, we have to square the scale factor and multiply the area of the smaller one by that square to get the area of the new one, right?
Yes.
Yes, miss.
Can we check if that is true? What's the area of this trapezium?
So much.
The area of that trapezium.
Yeah.
One, 2, 3, 1, 2. So 5.
Formula is a plus b divided by
A
2
plus b
over.
divided by 2 times the height. So
So
that's
that's
5
going
over 2.
2
That's 2.5
times
times the
2,
height. That's 5 units squared.
and this one will be what?
This one, wow. One,
We
two,
have
three,
one,
four,
two,
five,
three, four.
six, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 12 is 16 times.
8 plus 12 is 20,
Sorry, 8 plus 12 is 20 times.
divided by 2
Divided
is
by 2 is
10,
10 times 1, 2, 3, 4, 5, 6, 7, 8. That's 80 units. And
and
5.
5 into 80 goes 16, don't?
Yes, ma'am.
Okay. So we see that the area of this trapezium is 16 times the area of the original trapezium because we squared the scale factor. You see that?
Yes, miss.
Rainbow.
Right.
Rainbow.
So, hi Zane.
Say
Hi
good night.
Zane.
One.
Say good night.
Good night, Zane.
She's looking at the pens.
Oh, rainbow. Say good night. Purple. Purple.
All
Purple.
right. So what we're going to do when we do this again,
Yes,
Oh,
miss.
we're going to
Colors.
do enlargements with negative and fractional scale factors. All right.
Yes, miss.
All right. So that's it for tonight's class.
Yes, miss.
Um, what are you doing to Zane? Why is she calling out for help, Iman?
I'm not doing anything.
She's calling out for help. What you doing to the poor child?
I'm not doing anything.
Or she's calling out for help.
Orange.
Yes, I'm not doing anything.
Purple. These are all colors.
Say good night.
Hi, Zane.
Say good night, everyone.
Hi, Sue. How are you?
Hello.
How are you?
Oh, a
Say,
cookie.
I'm fine.
Fine.
All right, that's good to know.
Orange. It's a rainy, sunny day. A rainbow seems to say.
All right,
Rainbow.
guys. See you tomorrow.
Red,
See
you
you
know,
tomorrow, Miss. See you tomorrow, Miss.
green and orange.
Bye, sir.
Green.
I don't think I saw
Purple.
it because I haven't heard
All
from
the
him.
colors fairies day. Red.
Alright, Miss.
Red.
Bye,
Bye,
Miss.
John. Bye, Manny.
Red.
Bye, John.
Say bye.
All right, guys. Here's our scheduler.
See you tomorrow. See you tomorrow.
Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So, stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.